We want to be there when the melt of the surface starts.
And of course, it's the return of the sunlight and the increase in temperatures that start the ice to melt. But these so-called atmospheric rivers, they bring up a lot of moisture, heat, and also aerosols up to the Arctic that can have an influence and even speed up the melting.
And that's what we are postulating or hypothesizing happens with these atmospheric rivers. So you get an inflow of warm air that changes the surface enough that you have tipped over from winter to summer, which means that rather than what we are typically used to when spring at home is like a months-long process when things happen gradually, in the Arctic it might actually happen like that. It might happen over a few days. So before you have winter, after you have summer. And the spring was this long. Atmospheric rivers happens because of weather, and as you know, weather is chaotic. Low pressure systems come and go, and the weather changes from day to day. And therefore, if we were to pick a point where we want to go, chances are that atmospheric rivers would happen, but not there. And then the whole thing would be sort of useless.
So we have collaborators who will help us in looking at model data and model predictions. So looking really at weather forecast data, telling us, okay, now there's an atmospheric river coming towards the Arctic, but it's there, not where you are right now. So then we have to pack our instruments, we have to remove our equipment from the ice, steer Odin to that position, point it, and hope that this river really turns up, and then we start sampling.
So we don't have a specific point. If you look at the map and you draw a line from the North Pole to northern Greenland and then eastward to northern Svalbard and then back to the pole, you get like a triangle. Somewhere in that triangle. To be able to describe this in our climate models, we need to know how these things are working, what actually makes the melt start and what makes the freeze start in the autumn. We have lots of measurements about how the freeze starts, but we don't have much in terms of melt.
Yeah, we want to understand the processes behind these atmospheric rivers and how they bring aerosol particles up to the Arctic, how they influence clouds, and essentially this kind of data will be used to also improve climate models.
And make us more able to say something about what's going to happen to the sea ice in the Arctic in the future.